Okay, so this is 10.3. We're going to be able to create equivalent expressions. So that's your standard objective, to be able to identify equivalent expressions with at least 80% accuracy given your practice independent vocabulary. So the first one is terms. So those are parts of the expression that are separated by a plus or minus sign. So in this case, I have a plus sign right there. So this is one term and this is another term. In this case, this will be one term and that's another term. Coefficient is basically the number that is in front of the variable because they're multiplied. So in this case, this is my coefficient, that 3 is my coefficient. Right here, the 7 is my coefficient, the 7 is my coefficient, the 3, the 11, the 4, the 6, the 3, the 2. Okay, the 3 over here, the 5 over here. So those are the coefficients. And then electrons are basically terms with the same variable, or variables raised to the same power. So let me go ahead and give you an example right here, and then we'll go and do the ones following. So in this case, anytime you see a plus sign, that is going to be, it's a hint to tell you that that's a different term. So in this one, I have 1, 2, 3, 4, 5 terms. Okay. Now the ones in the blue, the numbers in front of the variables, those are my coefficients. Okay. And then the electrons will be, I'm going to look to see which ones have the same variable. So in this case, these two have the same variable and they are raised to the same power. So therefore, this and that, those two are electrons, okay? And you don't have anything else for the x. But in case it was like this, if it was like that, then those won't be electrons because this is not raised to the same power. It must be the same variable and it must be raised to the same power, okay? So let me give you one and you're going to tell me how many terms this one has, okay? So how many terms does this one have? Tell me the number of terms for this one. And what you're going to do is you're going to tell me the coefficient for this term right here. So what is the coefficient? Okay, so let's get to this one. So this one we're going to be able to identify equivalent expressions. So basically expressions that have the same value, right? That they're equal. So one thing that you can do is to substitute a value for the variable and then check, okay? Check to see if those two are equal. So in this case, let's for instance say that x equals to 1. So when I plug in x for 1, remember I'm not going to just write 51. That's wrong, right? Because this is 5 times 1. So when I have 5 times 1 plus 65, that will give me 70, okay? This one right here, I'm going to do 5 times 1 plus 1, which is plus 1 plus 1 is 2, and 2 times 5 is 10. Okay, this one right here, I'm going to do 1 plus 5 times 1, so that will give me 6. Okay, and let's look over here. So then I'm going to have 5 times 1 plus 1, so 5 times 1 is 5 plus 1 is 6. Right here, I have 5 times 1, then plus 5, so 5 plus 5 is 10. This one I have 5 times 13 plus 1. So 13 plus 1 is 14. And 14 times 5 is 70. So then I can match them up. 6. So these two are equal. They're equivalent. And then these two right here are equivalent. And then these two right here are equivalent. Okay? So that's a way that you can check to see which expressions are equivalent. So let me give you one to do for that. Okay, so go ahead and match those up. So tell me which one is, number 1, tell me which one is equivalent to that on this side. Number 2, tell me which one is equivalent to this. And number 3, tell me which one of this side is equivalent to that. Okay, now we're going to get to combining electrons. So in this one, we remember electrons have to have the same variable and they have to be raised to the same power. So then let's start with the x's. Do you see any ones that have an x? Yes. So these two, and they're raised to the same power. Yes, they're to the power of 1. So I'm going to do is I'm going to combine this two right here. So then I have 11x minus 7x, which is 4x. Okay, so if you wanted to, you can do this. That way you kind of remember. Okay, which is 4x. Okay, now let's look at our... we're done with the x's. There's no more x's. Now let's look at the y's. So y's, I have those 3, but this one is raised to the second power, and these are not raised to the second power. So then I'll start with the lowest power. So then I can combine these two right here. So then I have y plus 7y. Remember there's a 1 in front of the y, so that will be 8y. Okay, and then lastly, I have this right here. So then that one is on its own, so then I'm done. Okay, so then I have it 3y. So then what I do is I need to put it together. Remember, we start with the x's with the order of the alphabet, and then we'll also start with the highest power. We're gonna start writing it with the highest power. This is the one that has the highest power, so I'm gonna write 3y squared, and then my y right here plus ay, and then plus 4x, and I'm done. Okay, so the simplest form after combining like terms. So let me give you one to do. So go ahead and combine like terms and give me the simplified version of that. Okay, this one right here, we're going to model expressions using algebraic tiles. So 2 things that you have to know, at least for 6th grade, is that every squared little tile is going to be a 1, and then the long tiles, the rectangular tiles, are a variable because we don't know the value of them. Now in 6th grade, we're only dealing with positives. Once you get to 7th grade, you're going to deal with negatives. So let's just work with the positive tiles. So in this case, I have 3 groups of that. So how can I represent this? I can represent that by doing an X tile, which is that, and then 2 little ones, right? So that's one group, but I need 3 of those. So then I have to repeat that same process 3 times. Okay. Now for this one right here, I have 3 X tiles. So I have 1, 2, 3, and then I have 6 little ones. So can you see that they're exactly the same? And the easiest way to actually go about this is if you do use distributive property. Remember, you multiply by the h of the terms inside. So you have 3 times x is 3x, and then plus 3 times 2 is 6. So then you have that right there. I'm not going to ask you to model this on the Edpuzzle because I know it's hard. So then this one right here, let's go ahead and simplify expressions. So in this case, again, can I combine these two? Are they like terms? Yes, because they have the same variable raised to the same power. Then it's like saying I have 6 bananas minus 4 bananas. I end up with 2 bananas, but make sure that you keep the same variable with the same power. Okay, so this will be 6x squared minus 4x squared, 2x squared. Again, this is has to be the same, and then you subtract the coefficients. So let me give you one to do for that. Now this one right here, we're gonna use distributive property first because I cannot do that inside of the parentheses because there's some variables in there. So I'm gonna go ahead and do this right here. So I'm gonna use distributive property. So I'm gonna rewrite this 3a plus 2 times b is 2b, and then 2 times 5a is 10a. So then I can combine like terms. I have my a's right here, apples with apples, right? So that will be 10 plus 3, that will give me 13 apples. And then bananas, I only have those 2. So plus 2b, and I'm done with that one. That will be my final answer. Let me give you one to do. Go ahead and simplify that expression. Alrighty, God bless you. Bye. Thank you.